Okay, so homework 3 is all about exponential equations. We're going to just do the top half of the sheet here. So when we look at part A, we notice that 32 is a power of 2, so we should write that as 2 to the power of 5. And so now we can have the same base, we can compare the exponents. And so now we can say that x minus 2 will equal 5. And adding 2, we have x equal to 7. Note that it says the solution sets. So we'll write that in our set notation, listed form there, just with one element. Okay, so now let's go ahead to B. And we look at the same thing. When we see all of these numbers here, we notice that they are all powers of 3. So we'll rewrite these. So 9 becomes 3 squared, and we should use some safety brackets to be very careful here. Times by, that's 3 cubed, the power of x minus 1. Equals 81 is 3 to the power of 4, and that's the power of 2x minus 1, and that's multiplied by 3 to the power of 2 minus 3x. So now we've got powers of 3 everywhere. That's good. So now we'll multiply out the brackets, and we'll expand the brackets here, and 3 to the power of 6x, multiply the indices in brackets, multiplied by 3 to the power of, that'll be 3x minus 3. And here we'll have, multiplying again, 8x. 4 times minus 1 will give us minus 4. Multiplied by, again, keeping that the same there, 3 to the power of 2x minus 3. So now when we're multiplying with the same base, we should add the indices. So this means on the left we'll have 3 to the power of 9x, grouping the like terms. And here on the left we'll have 3 to the power of, the like terms there give us 5x. And minus 2. So we have the same base, we can equate the exponents. So 9x minus 3 should give us 5x minus 2. Grouping the like terms, to the left we have 4x, and the numbers to the right we'll have adding 3 gives us 1. So we should have as our solution set a quarter. Great, so let's hope that there's enough room for F. Let's look now to E. We have x to the power of 7 equals 128. So that's a power of 2, and it just so happens that it's 2 to the power of 7, which is handy for us. So now we have an odd power. Now, when we have an odd power, we can just simply equate the bases. So we don't have to consider a negative solution, because there isn't one. So we just say that x must be equal to 2 from here, with the same odd exponent. Solution set, we can just write as 2. Wonderful. So now for F. It's another example where we have an odd power, so it just means we can simply equate the bases as they are. So we have 4 minus 5x, all divided by 3, is just equal to 1 over x. Sorry, I should say 1 minus x. Sorry about that. So now we should multiply by 3, so we're just solving an equation here. You can skip ahead in the video, or you can watch me do this. Then we can take the x's to one side. Adding 3x would give us minus 2x. Numbers to the right hand side, if we subtract 4, we get minus 1, and x we see is a half. And as a solution set, just in listed form like so. Alright, so now back up to I here. We see we have an even power. We can see 4 is 2 squared, so we can simplify this, 2 squared. Let's keep this the same for now, minus 1 to the power of minus 2. Now to make these the same exponent, to have minus 2 as a power on the right hand side, we would then need to take the reciprocal value to make that true. So now that we've got the same power, we can equate the bases. But we should remember here that we have an even power. So what we have is basically a whole other problem here. We have absolute value of x minus 1 is equal to the absolute value of a half. So we have to consider the positive and the negative solutions for both of these this time, because we have an even exponent. So simplifying this absolute value equation, we would have the absolute value of x minus 1 equal to a half. We can just simplify that because it's positive anyway. Two ways to solve this. We could use a number line, which I'm going to use. I find it easy. We see that 1 is the breaking point, and the distance will be a half either side. So that will take us to 1.5, or we could say 3/2 here, and also to a half. So those are our two solutions, a half and 3/2. You can also solve it by hand by making two equations. The two equations would be, if we draw it up here, maybe have a bit of space, you could solve x minus 1 equal to a half, and also x minus 1 equal to minus a half. And solving those, you should get these answers. I'll leave that as an exercise for you. So for J here, we have got the powers here, we notice, are even. So what we should be solving is this absolute value equation. So the absolute value of 3 minus x equal to the absolute value of 2x minus 1. So either of those could be positive or negative. So we can use the absolute value function here. All right, so now we need to use our old favourite table method. We should first find the breaking points. So the breaking point of this is 3. The breaking point of this looks like a half. And so remember, you find those by solving equal to 0. Draw up a number line here, and let's divide this nice and evenly. Not a lot of space. Now half will be smaller than 3. And remember our regions here, this is the x values. So here we have x bigger than 3. We have x between a half and 3. I'll just draw it like that. And x smaller than a half here. All right, so now we need to make our expressions. Yeah, let's do that in a different colour. So for x less than a half, this is going to be positive here. So 3 minus x, I hope I have enough room, equal to, and then on the right we have that this is less than a half, which means it would be negative. And so to check that, let's just try 0. If we put in 0 here, we get minus 1. Okay, so that'll be negative, which means a simple way to do that is just to reverse the signs, 1 minus 2x. Let's try the middle here. So let's pick something, I don't know, let's try 1. So 3 minus 1, that's going to be positive, so that stays the same. And if we substitute 1 here, that's positive, so it stays the same. 2x minus 1. Bigger than 3, let's say 5. This makes this side negative, so we'll have x minus 3 equal to, and let's say 5's there, that's going to be positive. 2x minus 1, so just the same. Great, so now let's solve all of these equations. Add 2x and we on the left, and we have just x. And subtract 3, we get minus 2. So we need to check now, is this in this domain of up here? Is it less than a half? Yes, it is. We should also check each of the breaking points. So if we substitute a half, well, it's 0 on the right, on the left, that's not 0, so that's not a solution. For 3, 0 on the left, but not 0 on the right, so we can just say not a solution. Let's continue with our solving here now, and we get minus 3x. If we subtract 2x, subtract 3, and we get minus 4. Solving this, we have x equal to 1 1/3, or 4/3. That is in our range between a half and 3, so that is a possible solution. And the last equation here, we'll subtract 2x and get minus x, add 3 and get 2, so we have x equal to minus 2. Well, no, that's not bigger than 3. Okay, so these are our two solutions here, minus 2 and 4/3. So don't forget to write that in listed form. Normally the smallest will come first. And bingo. We hope you find this useful, and we'll see you in another video.